All right, hi. We're doing an APID, Army Correspondence Course Program, subcourse QM5127, Edition 5, Manager Patrolling Laboratory Safety Program, 101-523-2253. Introduction to Management of the Petroleum Laboratory Safety Program. All laboratories are subject to inspection from the regulatory agency that inspects laboratories, including health officials, city, state, federal governments, in addition with the representative of Occupational Safety, Health, and Administration, Environmental Protection Agency, Post Safety Office, Fire Deployment, and Facility Engineering may also be expected. Depending on your laboratory's location, continental United States, outside the continental United States, the size of the base laboratory, mobile laboratory, and or air mobile laboratory, and or previous accidents reported, you may receive a visit from any one of the or all previous mentioned agencies. The agency will check the different aspects of the laboratory safety program. All inspection will be inserted with your quarterly accident reports. The reports will pinpoint the problem area to learn events 1 through 3. Will give you an idea of the major items inspectors look for. Learning Event 1. Inspect the laboratory to define the existing and probable safety deficiencies. The aspect of the 92 soldiers' responsibility is usually gained through the experience of the use of existing field manuals, technical manuals, unit fire safety manual. Previous inspection reports, visit to another laboratory will help to familiarize the soldier who lacks the experience. The safety program laboratories is standard, even though the size of laboratories differ from both civil and military safety. Officers will look at the safety signs, safety of equipment, protective equipment, the storage of the samples and chemicals of the fire safety program, even though it is part of the safety program is not discussed in this lesson. Safety signs. All hazards must be identified whether they are visible or hidden. Appropriate safety signs must be posted where applicable. Conspicuous locations. Example of the common required signs are in the laboratory are exit, no smoking, eye protection must be worn, hearing protection must be worn, first aid station, eye watch station, safety shower, fire extinguisher. Safety equipment. The severity of the accident can be minimized with the safety equipment used, and it must be checked for serviceability on a routine basis. Example of the common required safety equipments are eye wash, shower, fire extinguisher, fire blanket, safety shield, fume hood, first aid kit. Protective equipment was not designed to enhance appearance of the soldiers. Often effectively when used. The wearing of protective equipment is mandatory. Example of the common required protective equipment are lab coat, lab apron, gloves, asbestos protection against heat, rubber protection against acid, and disposable protections against chemicals. Eye protection, safety goggles, safety glasses, approved face mask, eye protection, safety shoes. Storage samples of chemicals, cleanliness, caution, common sense must be exercised. Storing and handling petroleum products, 5 gallons of the gasoline or equivalent or equal to 450 pounds of the dynamite. The storage arm must be kept clean at the times of potentially most dangerous areas of the laboratory. The discarding of the used samples is governed by a local standing operation procedure of the local laboratory's mission and storage space. Generally, samples are retained for 30 days. Special samples are retained for 6 months. Chemicals. Chemicals include solvents must be stored correctly. Store chemicals in an area consistent with their property. Store volatile materials in well-ventilated areas. Store chemicals away from the other chemicals in which they will react violently. Examples of which the petroleum laboratory is strong acids, which react on the strong basis oxidizing agent, which react with reducing agents. Poisonous materials. All poisonous materials must be clearly marked. Poison. Report to your supervisor any poisonous material that is not needed. Storage area inspection. Check of the following inspection for storage areas. Any usual odor must be investigated. Aisles must be clean and uncluttered. Aisles must be 3 feet wide. Shelves must be clean and uncluttered. Steps of the stools and ladders must be serviceable. Containers must be tightly capped. Containers must be labeled. Damaged containers must be discarded. All slip hills must be wiped up. Sufficient amount of cleanup material must be on hand. Cylinders must be secured. Storage area must be ventilated. Storage area must have adequate lighting. Fire extinguisher must be on hand. Appropriate safety sign must be displayed. No items on the wooden pallets. Head bulk and the chemicals are stored on near the floor. Learning event number 2. Establish the procedure to deal with safety hazards, storage, and hazardous chemicals in the laboratory. The following steps are involved with establishing a new procedure: identifying the problem, potential problem, evaluating the problem, initiating action, presenting the fire safety committee, incorporating it into the fire safety manual. Examples: identifying the problem, you observe the technical turning on the compressor, however, there's not wearing an eye protection. However, evaluating the problem, ask the technician why he isn't wearing ear protection. Initiate the action. If the soldier was unaware of the requirement, advise him him that it is a requirement the soldier forgot to wear an ear protection. Counsel the soldier, if the ear protection was missing and unserviceable, replace, borrow one of the interim period to have the supply order of 2 pair presented on the agenda at the next quarterly Fire Safety Committee meeting, the adoption and incorporate the Fire Safety Manual. It is identified problem, a new situation, and take immediate corrective action. This presents its Fire Safety Committee. Lesson 3, training personnel, accident prevention procedures. During the initial interview of the soldier's first day, he should be made aware of the safety that is usually done by the non-commissioned officer in charge or the NCOIC. The concern must be shared with every soldier in the laboratory for the safety of the NCO. John, your job is to reinforce safety consciousness. Every quarter you will be asked to give a safety class discussion rather than lecture are more beneficial because the reports they require all technicians to take part. The discussion should include the review of the laboratory incident, review heightens awareness because it is currently close to the home, and the reinforcement because it may point out that something that is take for granted never thought about. The discussion should answer the following questions. How did the accident occur? Where did it occur? And how could it be prevented? The following provided with the example during the past quarter. Private Jones had to go in the emergency example of the room for the result of the acid burns to his fingers. The injury could have been worse, but it had been for immediate action taken or another action technician. One day in the question, Private Jones was performing 2 tetraethyl lead testing. He stated that halfway through his test, his fingers started to itch, and then he started to burn. Special Smith had Private Jones put his hand under the faucet and run water on his hand for 10 minutes. He later transported the private to the emergency room. How did the accident occur? When the accident occurred, the Private Jones was performing the evaporation phase of the test. He removed the watch glasses of his fingers rather than using tongs. What does the accident occur? The accident of the burn to Private Jones' fingers was present to the watch glass. On the watch glasses, nitric acid had evaporated, then condensed on the watch glass, and he should be removed from the have removed the watch glass on with a pair of tongs. How could it have been prevented careless due to the ignorance and indifference of the slovenly attitudes, although had the same report possible injury with the soldier? Ignorance of the technician should have been aware of the chemical reaction taking place, although the soldier has been school trained and had failed to use the proper laboratory techniques. He has violated another cardinal rule: never attempt to perform more tests than you can handle efficiently or safely. Indifference to senior technology assigned him to supervise was not present, and when the senior technician is not required with a junior technician at all times, he should have been in a general vicinity. Slovenly attitudes, the offense laboratory soldier becomes lackadaisical due to the routine until a new technician gains experience. He can accident prone. And that, my friend, was Managing a Laboratory Safety Program 101 52 523 222 2253 QM 5127. Managing Petroleum Laboratory Safety Program Edition 5.